Hi dear students, welcome back to computer science class. We have learned the concept of networking, the advantage of network, evolution of network, and how does internet work in our previous session. And today we have some important, very important technical topics for discussion. And these are the highlights of today's session. We will be looking at technical terminologies, okay, or network terminologies, basic terminologies using networks, components and different modes, components of networking and different modes of networking, and switching techniques. And the terminology switching techniques belong to different ways of sending data across network, of course purely technical aspects. Okay, so in today's topic we will be looking mainly at the technical terminologies and technical aspects of networking. So moving on, the first topic, elementary technology of networks or terminology of networks. Okay, elementary terminologies in network. The first one, okay, these are the terminologies, the most commonly used terminologies while referring to network or networking: nodes, server, network interface unit or MAC address or NIU, then IP address and domain name. Okay, these are the elementary terminologies. So let's look at one by one. The first one is node or workstations, and nodes are simply computers. Okay, nodes or workstations are simply computers. So it refers to computers that are attached to a network. These are nothing but computers that are attached or that are a part of network and are seeking to share resources. Okay, or we can say the computers in a network are called nodes. Sometimes we refer to nodes as some other devices as well. Okay, some other network devices can also be termed as nodes or workstations, but most of the time the terminology workstation refers to computer, and nodes also refers to computer. So computers or what? These are the computers that are attached to a network and are seeking for sharing resources, right? Seeking to share resources. The next one is server. Server is a computer with high configuration of hardware and software, high software hardware configuration. Okay, a computer that facilitates the sharing of data, software and hardware resources on the network. Okay, we know we have an architecture called server, client server architecture, and server is a central machine, and all the data and everything will be controlled by the server machine, and that machine will have a high configuration of high hardware software configuration. Okay, other than clients are normal machines, right? Yes. Then network interface unit, okay, or MAC address, and it's a terminology related to the hardware. Okay, network interface, network interface card, NIC card, right? NIC card is a part of our CPU where our Ethernet cables from different networks are attached to our CPU through that card. Ethernet card means a network interface card. Okay, or we can call it as Ethernet card as well, right? Ethernet card or LAN card or network interface card. Okay, you can see that card. Hope you get it, right? Ethernet cable from a network is connected to a machine, to the CPU, to that unit, to that Ethernet card or NIC card or a LAN card. Okay, there is a port, right? Yes. So that is what actually NIC card is, and it acts as an interface between our computer and the internet, or we can say network. Okay, so network interface unit or network interface card acts as an interface between the computer and the internet, or we can say network. Okay, yes. So a network interface unit is an interpreter that helps in establishing communication between the server and the client. Okay, so Ethernet cable from a network is connected to our computer, to our machine, through that unit. Okay, network interface unit or MAC, media access control. Okay, media access control unit, or we can say LAN card or Ethernet card. Okay, yes. So it's used to establish communication between what server and the client. Hope you get it. Yes. Then IP address, internet protocol address. Every machine on a TCP or IP or TCP/IP network has a unique identifying number called IP address. That means it's like a home address, right? That unique address, right? And we have our house address, home address. Okay, just for referring uniquely to us. Okay, to our family members or anyone. Okay, just like this, any machine connected to a network will have a unique ID. Okay, will have a unique number. That number is called IP address, internet protocol address. That will be a unique address. Okay, that will be a very unique address, and we follow 32-bit system of IP address. Okay, separated means 4 digits separated using dot. Okay, just like 192.168.1.1. okay, 192.168.1.1. okay, the last one, the 1.1, the last one indicates the system number. Okay, the system number, and there are different classes A, B, C, D. Okay, there are a number of classes in IP address. Okay, IP address classification. We don't go for that. Okay, it's somewhat an advanced topic, so there is nothing in our syllabus. Okay, so we leave it for the time being. Yes, IP address is a unique address given to each computer connected to internet. Okay, or to a network. Then domain name. It's a way to identify and locate the computers connected to the internet. It must be unique. It must also be unique. Okay. It is a way to identify and locate computers connected to the internet. Domain name. Just like we do give domain name for websites, right? Yes. And our school's domain name is what? www.merigiri.com, right? Yes. So merigiri.com. That's a unique address. And someone else can, of course, use merigiri.org, but no one can use merigiri.com. Okay, because merigiri.com is already used, so it cannot be used for someone else. Okay, someone else has to just modify marigiri. Okay, how is this marigiri? Okay, so someone else cannot use this, so because it's already assigned to a user. Okay, so it's unique. Okay, it's used for unique identification to locate a computer or a machine, okay, which is connected to the internet. Yes, so these are the elementary terminologies. So you must have a clear understanding of all these terminologies. Otherwise, in our coming classes, we will be giving notes, servers, IP address, domain names. Okay, so a clear understanding of all these terminologies must be there in your mind. Okay, yes, notes, computers, server. It's also computer high configured. Okay, network interface card. That's a card. That's a unit where cables from outside is connected to the machine. Okay, IP address, unique address of a computer that is connected to internet. Domain name. It's a unique name. Okay, yes. Moving on, components of data communication. To form a network, a lot of hardware devices are required, which are described as follows. Okay, these are some of the components of data communication. Sender, receiver, message, transmission medium, protocol. These are some of the components. Okay, who is the sender? One who sends a message, right? A device or a computer that sends a message. And who is the receiver? One who receives a message. A device or a computer that receives the message or the data. Okay. Then message. What is a message? It is information to be communicated. It may be a text, image, audio, video, or any other kind of text, any other kind of data. Okay. So message is the actual information that we want to, actual data or information we want to communicate, right? To be communicated. Yes. Or we want to communicate with. Okay. Then it may be text. It can be any kind of data. Okay. It can be a text. It can be an image. It can be an audio. It can be a video. Okay. So it can be any of these. Yeah. Then transmission medium. Transmission medium is a physical path through which the data flows from sender to receiver. A cable or wire or radio can be the medium. Okay. Transmission medium means, of course, there will be two ends, sender end and receiver end, right? Source and destination. Sender, receiver, source or destination. And actually sender sends some data to the destination or to the receiver. And in between sender and receiver, there must be a medium, right? A medium can be of two types. Wired medium or wireless medium, or we can say guided medium or unguided medium. Okay, and wired medium means with the help of a physical connection, just like copper wire, twisted pair, coaxial or optical fiber. Okay, it can be what guided medium, or we can say wired, having a physical connection. There will be a physical connection between the sender and the receiver. That's what wired connection is. So that is one of the transmission media. Okay, and the second is wireless. Wireless means there will not be a physical connection between the sender and the receiver. Instead, we use radio waves, mainly radio waves. Okay, it can be microwave. Okay, it can be infrared. Yes, we could see the application of infrared in our remotes. Okay, the TV remote, car keys. Okay, yes. Then that's what infrared is. Line of sight communication is needed. Okay, there must not be any hindrance between the sender and the receiver. There are a lot of restrictions. Okay, limitations of for infrared, but the most commonly used is of course radio wave. Okay, radio waves are used in almost all communication platforms like mobile phone, radio, TV. Then we can say Bluetooth, Wi-Fi, WiMAX, and all those technologies. Radio waves are most commonly used because it's somewhat very cheap. The blockage is not a problem at all. Okay, yes. So these are the two different media. Okay, transmission media, and microwaves are used in satellite communication, especially because it's a high strength wave. Okay, microwave. So these are the two transmission media, wired and wireless. Okay, so it can be anything. Yes. Then protocol. Actually, what is a protocol? Just like rules and regulations, right? Yes. Just like what the traffic rules, right? We have to follow some rules while driving. That's what protocol here in networking is. Yeah. Okay. So a set of rules and rules that governs the data transmission. It represents the communication methods which are to be followed by sending and receiving devices used by the followed by the sending and receiving devices. That means these are the set of rules and regulations to be followed while transferring data from the sender to the receiver. Okay, yes. So rules that governs the data transmission. So okay, knowingly or unknowingly we are following all these, right? Actually it works on HTTP, HTTPS. These are some of the protocols. TCP/IP is a protocol. Okay, HTTP stands for Hypertext Transfer Protocol. HTTPS stands for Hypertext Transfer Protocol. Secure, for secure sites. Okay, yes, just add some more security to the site. So these are some of the protocols. TCP/IP, we have already seen TCP/IP, Transmission Control Protocol, Internet Protocol. Okay, so these are some of the protocols we do follow knowingly or unknowingly. Okay, yes. So these are the components of data communication: sender, one who sends; receiver, one who receives a message, data or information to be communicated; then transmission media, wired or wireless; the path. Okay, then protocol, set of rules and regulations. Okay, yes. Moving on, modes of data transmission. Here we look at different modes of data transmission. We have analog or broadband transmission, digital or baseband transmission, then parallel communication, serial communication, and synchronous and asynchronous transmission. Okay, yes. So this will be definitely a new topic for you. You might have heard of this. Okay, so listen to me carefully. The first one is analog or broadband transmission. You know what analog is, right? Analog, most of the time we refer to signals as analog. Okay, analog signals and digital signals. Analog signals are signals which are having continuously varying the format. Okay, continuously varying format. The signal is a radio frequency signal or analog, which can consist of continuous electrical waves of varying amplitudes. Okay, varying amplitudes. It looks like sine wave. You know that? Yes. That means it's of what? Continuously varying structure. Okay, continuously varying pattern, and normally it transmit data using copper wire. Okay, yes. When we transmit data using copper wire, it's of what? Analog form. The signal may be varying. Okay, continuously varying. Okay, yes. So signal is a radio frequency signal, or we can say analog. It's of analog signal which can consist of continuously varying electric waves. Okay, electrical waves, varying amplitudes. Okay, require modem for transmitting data over the baseband medium. Example, telephone network. You know, the major component in analog transmission is copper wire. You know, copper wire transmits signal or data in the form of electric pulses, right? Yes, electric pulses. You know, electricity is varying. Yes, so here what happens in analog or broadband transmission is data carries from the sender to the receiver in the form of electric pulses. Okay, because the medium is what? Copper wire, right? Yes, it can carry only what? Continuously varying electric pulses. Hope you get it. Yes. Then digital or baseband transmission. It's just opposite to analog. Digital means discrete. Okay, discrete quantities, and digital signals are represented using discrete quantities like 1 and 0. You know, 1 and 0. There will be only two states. Okay, 1 and 0. Yes, no special device for conversion of signal to be transmitted over baseband. Okay, in our previous case, analog or broadband, we have seen modem is needed, but here in digital, nothing is needed. No special devices are needed. Okay, then the signal is a group of discrete electric units which is transmitted in rapid succession. Okay, that means digital or baseband transmission is a form of transmission that consists of digital signals, digital pulses. That means in the form of 1 and 0. Okay, that means discrete quantities, discrete electrical units or electric units. That is 1 and 0. So hope you get the difference between analog and digital, right? Analog means continuously varying physical quantities, and digital means fixed, that is discrete quantities, 1 and 0. Okay, yes. Then parallel communication. It's another mode of communication. Okay, data transmission. When data is transmitted through multiple wires, each wire carrying each bit, it is called parallel communication. That means when we send data from one place to another place and to receiver, it consists of what? Transmitted through multiple wires. Okay, parallelly. You know, in physics you might have learned parallel and serial communication, right? Parallel means there will be multiple wires. Just think of multiple wires. Okay, so the data is transmitted through multiple wires and at a time. Okay, each wire carrying each bit, and it's called parallel. Okay, then the next one is serial. Of course, serial means there will be only one wire, right? Only one. Where when bits are sent one after another in a series along a wire, along a single wire, it's called serial communication. Okay, that means in the case of parallel, we have seen that there will be multiple wires. Okay, and that one bit is transmitted through one next to next, okay. Yes, but here in serial communication, what happens is there will be only single wire and data is transmitted one after other. That's it, one by one, okay. There will be only one wire, right? Yes. Then synchronous or asynchronous transmission. Synchronous or asynchronous transmission. It's a new kind, of course. When sender and receiver synchronize their chips before transmission, that is, the sender first sends control characters or control signals to the receiver and then sends the actual data. It's called synchronous transmission. I hope you get it, right? That means, okay, actually the data transfer occurs between the sender and the receiver, and just before sending the actual data by the sender, it sends a control signal. Okay, it sends a control character from the sender to the receiver. Okay, only after successful completion of sending sending control signal from sender to receiver, it starts sending the actual message, the original message. Okay, yes, it's called synchronous transmission, and the advantage is faster than asynchronous mode, then costly and complex setup required. Okay, it's somewhat costly because we do send control characters or control signal first, then only we can send the actual data. So it's costly and complex setups are required. Okay, we have to ensure both, right? Sending control characters as well as what the actual data. We have to monitor everything. So complex mechanisms are needed. Okay, yes. So the next one is asynchronous transmission. In asynchronous transmission, data is preceded and succeeded by start and stop it. Okay, respectively. No synchronization is required. Synchronization means checking, right? Checking whether the route is right between the sender and the receiver. But here in asynchronous transmission, there is no such synchronization happens. Okay, required. Instead, it can be data can be sent directly. Okay, hardware required is simple and cheap. That's one of the advantages. Okay, then disadvantage is slower than synchronous mode. It is slower than synchronous mode. Okay, yes. So this is a basic difference between synchronous and asynchronous. In synchronous, we need synchronization. In asynchronous, no need of synchronization. Synchronization means sending control signal from the sender to the receiver. Okay, and asynchronous, no such. Okay, data can be sent directly. Yes, but in the synchronous, first control signals are transferred. Only then the actual data is transferred. Okay, so this is all about modes of data transmission. Analog, continuously varying digital pulse means signals. Okay, then digital, discrete quantities, parallel, multiple wires through which data are sent. Okay, then serial, only one wire data sent. Synchronous and asynchronous. Synchronous means we have to synchronize the channel first. Okay, yes, after that we can send. That means control signals. Asynchronous, no synchronization, directly sending the data. Okay, yes. So next is a very important topic. Okay, different ways of sending data across network. This is completely technical. So your kind attention is needed. Okay, please be very careful. Yeah. So there are different ways of sending data from one node to another node through network. It can be in the form of calls, messages, etc. Actually, we are going to look at different ways of sending data across network, right? It can be any kind of data. Data can be of any type. It can be voice data. Voice data. When you call someone, you're transferring voice data, right? You're transferring data over voice. Then it can be text data. It can be video, audio, graphic, any kind of data, right? It doesn't matter what the kind of data it is, but we have to ensure a mechanism for sending any of these data. So we will be looking at different ways of sending data from across the network from sender to the receiver. Okay, yes. Then there are three techniques. It's called switching techniques. Circuit switching, packet switching, and message switching. Before heading, I'll give you just a brief on the switching techniques. Okay, circuit switching is a switching that mainly happens in voice communication. Okay, when you call someone over phone, okay, over a LAN phone, connected phone, that means between the sender and the receiver, there will be a physical connection. Okay, that's what circuit switching is. And packet switching and message switching comes under internet communication. Okay, when you send some kind of email or WhatsApp, it's done using packet switching, or it can be message switching. Okay, but there is difference between packet switching and message switching. We'll be looking at that. So network switching. Network switching. A network is made up of several interconnected nodes. Nodes. What is a node? Yes, we have seen it. Node, right? Workstation, computers. Yeah. Then this can be a point-to-point connection or star topology between pairs of devices. As I've already mentioned in the previous session, point-to-point and star topology, right? In point-to-point, each computer in the network will have one-to-one connection with one to another, right? Yes. But in star topology, there will not be any direct connection between all the devices. It is practically impossible. Okay, yes, because it will be very costly, right? If you try to do that, it will be very costly because that much cable length will be needed, is required. Okay, so we will not go for that. Okay, if it's a large network, so star topology is used. Okay, there will be a central machine, and all the cables or things will be connected to that particular device. Okay, that acts as a junction. Okay, yes, it will control and monitor all the data transmission. Okay, yes. So switching techniques are used to transfer packets of data from one port to another, a node to another. Okay, one port of a node to another node. Okay, yes. So network is made up of several interconnected nodes, and this can be point to point or star topology, following star topology or network. Okay, yes. Switching techniques are used to transfer packets, and switching techniques deals with how do we transfer data, the technical aspect of transferring data from sender to receiver. Okay, and these are for the delivery of data with accuracy. Various type of switching techniques are used, namely circuit switching, packet switching, and message switching. The first one is circuit switching. Okay, circuit switching provides end-to-end connection between two computers. Of course, these are connected. It is established usually in a telephone network where one person is making a call and another one is receiving a call. In a telephone system, the communication must be established between the two participants, that is sender and the receiver. The circuit is established between these two participants before the transfer of data takes place, right? Yes. And in this technique, the entire link remains dedicated, and no one means no other user can intervene, right? Yes, can use it even if the path remains idle. The following actions take place during circuit switching. All a request signal is sent by the sender to set up the connection with the receiver. It establishes a physical connection between the two participants. Okay, all intermediate nodes are identified. These nodes are also called switching nodes, and if the destination node is available, it sends back the acknowledgement of receiving the signal. Okay, data transmission begins. When the data transmission is complete, the call can be terminated. Okay, circuit switching is a connection oriented service. In this technique, there is a dedicated link between the sender and the receiver, and no other call can be made during this link, even if the link remains idle. Okay, remains idle. Yeah. So I'll give you a brief of circuit switching. Okay, we can summarize it. Yes, circuit switching is a kind of communication mainly used for voice communication. Okay, suppose you call someone who is distant, who is at a distant place. Okay, and you're making use of your land phone. LAN phone means it is kind of wired, right? It's wired. Okay, yes, that means the connection comes to your phone through underground cables. Okay, cables. Okay, mainly use cables. So between the sender and the receiver, there will be a physical connection. Okay, there will be a physical connection. So just before transferring data, just before start transferring data or starting the voice call, a dedicated physical connection should be established between the sender and the receiver. Okay, a dedicated physical connection should be established between the sender and the receiver. That means when you dial a friend, what actually happens is it is not getting connected directly, right? And just before attending your call from the other end, there comes a delay of 5 to 10 seconds. And in that 5 to 10 seconds, what actually happens is it is trying to establish a connection, right? It is the network is trying to establish a connection, that physical connection, that dedicated connection. Okay, it's called dedicated physical connection. And after that, it will be getting connected, and you can start communicating. Okay, start communication, and of course, that path will be completely dedicated to you. Okay, that path will be completely dedicated to you. No one else can intervene. Okay, no one else can talk in between. Yes, while data transfer occurs. Okay, so that's what actually happens here in a circuit switching. So in circuit switching, a dedicated physical connection should be established between the sender and the receiver before the actual data transfer. And once the circuit is established, you can start transferring data, and the path will be completely dedicated to you, exclusively dedicated to you people. Okay, to sender and the receiver. That means no one else can get into your call. Okay, yes. Then after completing the data transmission, we can stop it, right? Yes. So this is what actually happens here at circuit switching, and this technology or this technique is mainly used in voice communication. Okay. So here is a diagram showing circuit switching. Okay. Here is a sender and here is a receiver. Okay. Yes. And you can see intermediate nodes. These are some computers or devices. Okay. this called intermediate nodes. Yes. Then the second one is packet switching, and in packet switching technique, the entire data is divided into small fragments called packets. Each packet is of fixed size, usually 128 bytes or 512 bytes. Packet switching is similar to post office operation. Each packet has a source address and a destination address for being transmitted. Okay, in the same way, postman delivers a letter to a specific address. Okay, there is no direct connection established between the sender and the receiver. Each packet follows different routes, and therefore the packets are delivered in a random order of the destination address. Okay, it is a TCP protocol which then arranges all the received packets in sequential order. Okay, during the transfer of packets, each packet has to pass through several intermediate nodes. So each intermediate node checks for the destination IP address. Okay, here is what diagram showing that. Okay, packet switching offers a connectional service as well. Data is fragmented into small packets, and each packet is fixed size in packet switching technology. Okay, I'll make it simple for you. Yes, actually I've explained it in your previous session, right? Packet switching. Okay, packet switching. Actually, what is a packet? You know what switching is, right? Switching means transferring data. The technology related to the transferring of data from one place to another place. That's what switching is. And in packet switching, we have to understand what packet first, right? Packet means packet is a logical unit of information, and packet is a logical unit of information. For example, hi WhatsApp. That's a message we are sending to the receiver. Okay, sending to your friend. So it will be divided into fixed size messages. Hi WhatsApp. Suppose for an example, we can have 3 packets. Okay, hi what's up. Okay, yes. So each packet will be of having same size. Normally it's 53 bytes. 48 bytes are for storing the data, and 5 bytes are for storing the header part. You know, header part contains information like sender address, receiver address, acknowledgement number, okay, message number, control information, lot of things, right? It actually controls the data transmission, the header part. So each packet will be added to attached to a header. Then header contain all the information regarding the packets and the other kind of other matters. Okay, yes. So just like sending you people to a program from our school to that program. Okay, and there are 3 students, and all the 3 must be reached there to attend or to participate. And you may not be taking the same path, you may be taking different paths, right? Yes, it's up to you. Here also, each packet can take their own path. Okay, it's based on the availability of path, right? Yes. So when we send hi WhatsApp, what actually happens is hi WhatsApp will be divided into fixed messages, and this packet will be transferred. Okay, transmitted, and each packet may be taking different paths, but the condition is just after reaching the destination, it should be reassembled to get the actual message. Okay, yes. If something is missing, it gives an acknowledgement that something is missing. Okay, then the sender has to send it again. You could see in WhatsApp, Facebook, everywhere, right? Yes, the acknowledgement mechanism, double tick, green tick, yes, all that. Okay, yes. So this is what actually happens in packet switching. Then packet switching is actually the one we make use at the time of transferring data using a mobile phone, internet, whatever it is. Okay, wireless and wired mode of communication. Yes. Then message switching. Message is another unit of information. Okay, yes, you know, packets are of the same size, but message can be of varying size. That's the difference. In message switching, the sender sends the data to switching office first, which is then stored in its buffer. Okay, it then checks the availability link, and then if it's free, the data is relayed to another switching office. The process goes until the data reaches the destination. The data is first stored in a buffer and then to the next switching office. Okay, it's called store and forward switching technique. Okay, then message switching is a store and forward switching technique where there is no direct connection between the sender and receiver. Always keep in mind, in communication there will not be any direct connection between the sender and the receiver. It is impractical, you know, it is not practical. Of course, it is not feasible as well, because a lot of cable length and high quantity of cable length, high sophisticated technologies are needed, right? It will be very tiresome task for us, because it's not possible, of course. Just think of it. Yeah, so there will not be direct connection. Instead, there will be intermediate computers or intermediate nodes, and we are connected to that intermediate node, and that will be connected to another node. Okay, that is how it occurs. Okay, yes, yes. Here you can see these are some of the nodes. You can see this is a node, this is another node, this is another node. Okay, these are the nodes. That means this is the sender, this is the receiver, and these two people are not directly connected. Instead, this sender is connected to this one, right? And this will be connected to this to this, and we know the path taking is dynamic. the path taken by the message is dynamic or the packet is dynamic. It's up to the availability of the packet. Okay, and in store and forward mechanism, in packet in message switching, what actually happens is when you send something, sender sends something, it will be stored here because this route is busy and this route is also busy. Okay, this node is busy, this node is also busy. What happens is you will have to wait. Your message has to be stored here for some time, right? And soon after getting any of this node free, you can start transferring to this node. Okay, suppose this is busy at the time as well. Okay, so you have to send it to this node, then to this node, then to this node. Okay, then to this node, finally reaches the destination. That means data will be stored temporarily in computers or in devices, and only after getting the path free, you can start transferring it. Okay, that is what store and forward mechanism is. Okay, yes, just like when we go to somewhere some other place, how do we go? Suppose we are taking a bus. Okay, so first we will be getting into the bus. Okay, then we'll got into a town, and you will be stored some time because the connected bus is not available. Okay, you'll have to wait for some 10 minutes, 15 minutes. After getting the bus, you'll be getting into. Okay, you can go to the next place. Okay, that means you will be stored in some places temporarily. Okay, because the path is not free, of course. Yes, then sometimes you have to follow some other path as well, because the path you're intending to take may be traffic. Okay, may have some traffic, so you'll have to take some other route. Okay, that's what store and forward is, and this is dynamic. Okay, the path taken by the node is dynamic. Then the last topic, differences between circuit switching and packet switching. The circuit switching reserves the required bandwidth in advance, because okay, in circuit switching we have seen a dedicated path is established between the sender and the receiver even before the actual data transmission. Okay, where packet switching uses bandwidth as and when required by the packet to be transmitted. Okay, it's dynamic. Circuit switching is a fast technology as compared to packet switching, which is slow mechanism of transferring packets. Okay, circuit switching very fast because first we establish a connection, then you can transferring data. Okay, the delay comes at the time of connecting. This establishing the connection, but after that you can continuously transfer data without any delay. But in packet switching there comes some delay. Okay, circuit switching requires a dedicated path. Once the connection is established, the communication path and relay dedicate that. Okay, yes, you know that. Where in packet switching, the packets may use the dynamic path. Okay, in circuit switching the path is overloaded. If the path is overloaded, the call is blocked and the communication is delayed. Okay, if you're talking to someone and he's busy, you cannot talk to him, right? Yes, that's very common sense here. But in packet switching, packets are allocated to different paths, so there will not be any problem. Okay, packets are dynamic, means it takes dynamic path. Circuit switch networks are used for phone calls, and packet switch are handling data. Okay, mobile data or any data. Packet switching is more efficient because the cost of link is shared by many users. In circuits and telephone message sent unbroken, the message received in the same order it is originally sent. Okay, in packet switching, the message is broken into small packets and randomly sent from the source and received in random at the random order. Okay, and which is then sequentially arranged. So that is what here comes the importance of message number. Okay, hi WhatsApp, hi what second, up third. So it should be rearranged when it reaches the destination. Otherwise, it will be illogical, right? It may be reaching like upwards high. Okay, it may be somewhat illogical. Okay, so it should be rearranged. Okay, it should be rearranged properly. Yes, here comes as I've told you, here comes the importance of message number. Okay, packet number. So this is all for the time being. Let's have a quick recap. Okay, elementary terminologies, then components, then modes of data transmission, and the different ways of sending. Okay, circuit switching, packet switching, and message switching. Okay, then we have seen the differences between packet switching and circuit switching and packet switching. Yes, so this is all for the timing, and we have gone through some of the new terminologies. Okay, of course this will be something very new to you, so keep going through. Okay, yes, don't stop. Okay, so this is all for the time being. Thank you for watching. Have a nice time. See you in the next video. Take care.